For this next tutorial, we're going to be talking about other types of code blocks, specifically scopes and libraries. Scopes are like territories. If you see all this white space down here, this is like no man's land. So this is the global territory here. Everyone has free reign over this territory, but you can create your own territory, and you need to give it a name, obviously, like scope high. And then in this territory, you can have your own private things. They're only located in this territory. So they're like organized no man land areas, which are pretty nice. And with them, you can use what's called the private keyword. So let's create a globals block here so that we can make some variables. So you could go like private integer I. And now this I only exists within this scope here, in this territory. If I wanted to read it out here like function name takes nothing, returns nothing, and function, well, this is a global variable, so I should be able to read it. Set I equal to 5. There we go. Let's save it now. Oh my gosh, undeclared variable I wonder why that is. Let's look up at the globals block here, where I is. Where is I? It's somewhere. And globals. Oh, there it is. Notice these underscores here. What vjass does is add the scope name and then a random number of underscores and then the variable name. So that's why this I does not exist, because it's private, so it gets all that special stuff. You can also make public variables, which is the scope name plus one underscore and then the variable name, and so then you could just type in hi I, and let's go ahead and make that public to see. However, never, ever, ever use the public keyword. This is ugly. This is a pain. It is not accepted in general resources on the vjass section. If we go into the vjass section there on Hive Workshop, it is frowned upon heavily. People will hate you for it. People will tell you to get rid of the public. Don't use them. If you want only local to the scope, do private. If you want it to be public and do something for the scope, you want to do like hi I or something like that. Notice the camel casing here. Whoop. Or I hi. There we go, that looks better. And generally, global variables like this, in general, are also frowned upon. So you don't want any global variables whatsoever. You can have global other things, but like global functions, but not global variables. That is a big no-no. So let's go ahead and get rid of this now. So we can have our private variables. We can also have private functions. We can have private anything. A scope is just a category, think of it like that, or a folder. And just like regular folders, you can have folders inside of folders. Folders can hold whatever you want them to hold. So like scope, boo, and scope. You could even go private scope boo, and now nothing can see out here. And just to try it out, globals integer I. This integer I will now be private to this scope, because the scope out here is private. If we try to access it again, I'm just going to do it down here. Set I equal 5. It shall not work. It did work. Okay, it does not properly do private scopes. So there you go. Private scopes are useless. Just do plain scopes, I guess. So just scope boo and scope. Then if you want this variable to be private, now it will be private for only this scope boo here. If you try to set it out in scope high, it would not work. So let's try that out. And syntax error, undeclared variable I, because it's for boo, and we can go as deep as we want, as many scopes as you like. Now, one thing you might be wondering is, how am I getting this code here to automatically run? What am I doing there? Because if I just had a function hello takes nothing, returns nothing, and function. How do I make it run? Obviously I can call it down here, but let's say I'm not using this core here. Let's say I'm just doing general mapping. How do I make this run? Well, there are actually 4 ways, and I'm going to cover the first 2 ways in this tutorial. And the first way is through scopes. And when you're doing function running for scopes, you cannot have nested functions whatsoever. Use what's called the initializer keyword, and that just goes after the scope name. And then you put in the function name there, for example, hello. And the function has to actually be inside the scope. For initializers, you always want them to be private. Always. So there we go, private function hello. This will actually run now. So if we did call print hello, this will print hello. And there it is. Hello. Another way is by using what are called library initializers. A library is exactly like a scope. It's a territory. It works largely the same way. It has initializers, hello, private function, hello, takes nothing, returns, nothing, and function. It can contain scopes, functions, globals. It is exactly like scope, except libraries cannot contain other libraries. So, what really is the difference between a scope and a library then? A library is always placed at the very top of the code. Remember the code ordering stuff here? A function can only call another function above it. Libraries are a way for public resources to require other public resources. So that's why every public resource is always inside the library. If we look here, damage calculator, for example, I don't know if this is a good example. Oh, it is. Library damage calculator. So whenever you make a public resource or pretty much anything, you always want to put it in a library. That way other things can require it and it can require other things. Libraries are a way to organize your code. And they are put up one after another in order. So if I did library boo beneath it, and library, this is put to the top of the code, then this is put to the top of the code. So it'll end up being boo, then woo. And if we actually put in a syntax error here, I should probably private function hello too. Oh. Returns nothing. Brilliant. And then A there. And if we look here, it's first hello too, which is right there. And then it's hello, which is right there. This is because this is placed at the top, then this is placed at the top. So whatever, it goes in reverse order, because it reads from the top down and keeps pushing stuff to the top as it encounters it. So that's what's going on there. Now to actually make a library require another library, we can use one of a few keywords. There's the uses keyword, which is the one I use because it's the shortest, and then there's the requires keyword. The actual order here is the library, name, initializer, then requires, and then list of libraries. It can either be comma separated or space separated, doesn't really matter. So we can say this requires boo. Now what will happen here is boo will still be at the top, so why don't we move this down here, requires woo. Now woo will be the top one. If we look here, hello 1, hello 2. Because boo requires woo. And we can make other libraries down here. Library hi requires woo, boo, and library. Whatever. And if you notice, the initializer keyword is not required. The requires is not required. And let's change this back to uses, because uses is just shorter and smarter. So those are libraries in a nutshell, and how to start code with libraries. and scopes as well. And that concludes this part of the tutorial.